All right, PCI Fundamentals, Part 4, Introduction. So let's just get right into it. This is more for assessors, or if you're interested in what assessors are looking for as it relates to PCI data, this is a good presentation. But if you're really interested in the gambit of it, you want to look at all of these videos. All right, so in this presentation, we're looking at cardholder data, network segmentation, mod 10, scoping the data discovery, or scoping the cardholder data discovery aspect of doing PCI certifications. So let's talk about full track data. There are two types, track 1 and track 2. Track 1, as you can see here in the presentation, we have 79 characters. Track 2, 40 characters. And usually that's used for your older systems that are using dial-up. All right, so these tracks are located on the magnetic strip. So processing terminals may read the strip or the EMV chip. So when they're processing, you slide your card through or you put your card in, it's either going to read the strip or the EMV chip. EMV, as you may or may not know, stands for Europay, MasterCard, and Visa. They're the ones who created that standard. So a couple of points here. Track data is stored on both the magnetic strip and EMV chip. So I just showed you track 1 and track 2, where they're on both the magnetic strip and the EMV chip. The difference, the EMV chip also contains the CVV code. So when you call and they say, well, I need the CVV code on the back of your card. That's also on the chip, but it's not on the magnetic strip. And the reason for that is now if someone steals the chip information and they try and actually make a magnetic strip or make their own credit cards, it won't work because the data is different. The magnetic strip has enough information for criminals to use in card not present transactions. So basically what that means is if someone steals the information on the magnetic strip, they can use it to make a purchase where cards don't have to be present. For instance, if you're calling over the telephone or if you're putting information into a computer, the actual card may not be present when you're putting that information in. Merchants are not permitted to store track equivalent data after the authorization process. So after it's authorized, you're not supposed to store that information. Cardholder data can leak out of known storage locations and also unknown storage locations. So it's important to find out where that cardholder data resides. Sometimes it's in places you wouldn't think it is. So card data inventory. I'm going to try and fly through these slides. Basically, in my study, these are the things that are the most important things as relates to our objectives. So card data flows everywhere, therefore a thorough investigation should take place to determine in which systems it resides. When it comes through your network, it can be on a web server, it can be on an e-commerce server, it can be obviously on a point of sale terminal. So you want to make sure that you go through your entire flow of where that cardholder data is going in your network. And you want to record the following things: the system name, the data that's actually stored, why is it being stored, because remember I just told you, you don't want to store track data. Reason for storage, retention period, how long do you have it? Some people keep it for 30 days, 90 days, or just during testing, and I'll talk a little bit more about those things. And if I don't mention something, just send me an email or send me a comment and I can send you information back. Protection mechanism. How are you protecting the data that's being stored on that system? If it is determined that card verification code, that's the CVV, PIN or track data is stored, this would automatically raise a red flag because storage of these data elements is prohibited. Like I just said, you're not supposed to store anything. You're not supposed to store any of those things unless, okay, so the question is, who is allowed to store track data? The issuer. Remember in the previous videos I talked about the issuer being the bank. So they may have track data, cardholder data, but those things that are used, those tracks that are used in order to create the cards to send to you. So they may actually have that information, or they may be testing something. but they are working in conjunction with the payment brand. So they may be working with Visa, they may be working with American Express or MasterCard in order to create the cards, and they're working in conjunction with them. So the issuers with a specific reason may be allowed to store track data. That's a very important point. Card data used for troubleshooting. All right, so I mentioned testing. So when you have cardholder data and you're troubleshooting your system, let's say you found that there's a vulnerability or a leak, or you're just creating a new application or a new system and you need to test. Well, cardholder data can be used for troubleshooting. So my points here: only enable storage when needed for troubleshooting and disable storage when troubleshooting is complete. Once it's done, it's done. Make sure it is deleted by the proper methods. Ensure that all data is securely deleted as soon as troubleshooting is completed following a defined data destruction practice. I just said that. And ensure only the data specifically required for troubleshooting is captured. So you don't want to just have a whole bunch of data that you're using for testing, but be specific in what you are using and what you are testing. That's the only way that you can have cardholder data. So where may it be? Where may this track data reside in the network? It can reside on databases, flat files, log files, debug files. Debug files meaning, again, when we were testing, finding the bugs and you're debugging, and your debug system is capturing data. So it may be in a debug files. Log files, basically each system is, you should be recording what's going on in the system. Every time someone logs in or logs out, you should be recording, and those are logs. Systems that commonly store track data: point of sale systems, point of sale servers, authorization servers. So they may store track data, but again, as soon as the transaction has been authorized, that data should be deleted. All right. It is important to note that card verification codes or values are not required for recurring card not present transactions. So if you call someplace and they need your CVV, they shouldn't need it again. It should be for that first purchase or that first authorization. Afterwards, it shouldn't be needed. And they shouldn't be storing it. So they shouldn't have to go back to your CVV code. Locations where it's located, same locations. I did add paper here because a lot of times people will write down the CVV code. So that's the only difference as it relates to locations. And systems, web servers, and kiosks. So a lot of times people are purchasing things with kiosk, and sometimes that CVV code may be stored there, even though it's not supposed to be. But as an assessor, you're supposed to find that, find where it could be stored, and that's a place: web servers, kiosk, and authorization servers. All right, so let's say you find some numbers and you don't know if it is truly a card number. So there's a test you can do. So let's say you run across a database and you find a number, this particular number that's right here, 440-898-55-000000585. So how do you determine whether or not that's an actual card number? Well, the mod 10 is a process you use to find out whether or not it's an actual card data, if it's an actual card that can be used. 5. So basically you take every other number, multiply it times 2, and if it's over 10, subtract 9 from it. You add up all the numbers, and if it's divisible by 10, it's an actual card. That's why they call it mod 10. This particular one actually equals up to 60, and that is divisible by 10. So you take this number, you just bring these numbers down, but every other number, like this 8, this 0, this 0, you multiply times 2, you get 16, subtract 9 from it, and put that number down here. Add up all of these numbers, and it should be divisible by 10 if it is an actual card number. All right, I'm trying to run through this because I got some other things I need to do in other presentations. So this is called mod 10, but this really isn't. This is actually, I should call it something else. Hold on. Network segmentation. Forgive me. All right, so basically you have the internet, you have your mobile users, and your web server. But you notice there are no firewalls in between your mobile users and your application server, audit logging servers, your corporate server, that should be server. So this is not good. Everything, all of your cardholder data could exist anywhere on your network because there are no firewalls. All right, so let's go to the next one. And this also should say network segmentation. So take a look at this one, and what do you think? Does this show proper network segmentation between cardholder data and public data? So you have the internet, you have your point of sale terminals, you have a router, again, corporate server, audit logging server, application. So you have a router here, but there are no firewalls. So it is not considered prudent. So cardholder data, everything is in scope on this diagram, just as the last diagram. All right, so let's look at another one. I think I skipped one. All right, so you have the internet, point of sale terminals, you have a firewall separating this from this, and you have wireless as well and a firewall, which other devices could be connected to. But you can see here there is network segmentation. You have a firewall which separates the corporate servers and all the other servers, also separating the wireless access from the corporate LAN. So this is a proper example of network segmentations. So then only this area will be in scope for cardholder data. So some of the things that you should look at if you're trying to find cardholder data, these are some of the questions you should ask. How does the organization receive cardholder data? How many applications store, process, or transmit it? What databases are used to support them? Operating systems? Is there a DMZ? Are there firewalls? Is PAN, as personal access numbers, I believe, stored on the point of sale systems? Do call centers store, process, or transmit credit card data? Those are some of the things that you should ask if you are doing an assessment. And that's what your assessor should ask. There are other things. I'm making more videos. So if you have any comments or questions, just send me a message. That's all I got for today. I'll talk to you soon. Thank you for watching.